In this module, we will talk about ceramic and glassy materials. So what are the ceramic and glassy materials? Ceramic materials by definition are ionically bound. They are hard materials, both electrically and thermally very stable. So ceramic materials, they are स्टेबल थर्मली इलेक्ट्रिकली ये इनकी प्रॉपर्टीज हैं कि दे आर हार्ड मटेरियल्स एंड दे आर आयोनिकली बाउंड. So what are the examples that include these materials? They are alumina, silicate nitride, magnesium oxide, silica, calcium oxide, and some other compounds. Ceramics are characterized by being hard yet brittle. Therefore, in many cases, they are used as composites where they are mixed with other chemicals to increase their mechanical performance. So, जो ceramic materials हैं एक तो ये hard हैं, so and then brittle. Due to this property, they are used as a composite, and in composite we know that they can integrate with some other material like metals to increase their mechanical performance. Ceramics exist both in a crystalline and non-crystalline form. So दोनों forms में exist करता है, crystalline and non-crystalline. So let's discuss some examples in ceramic and glassy materials. The first one is porous alumina. Porous alumina membranes produced by anodic aluminum oxidation are characterized by having hexagonally closed packed channels with diameters ranging from 10 to 250 nanometer or greater. So जो porous alumina की जो membranes हैं ये aluminium की oxidation से बनती हैं and then they characterized क्योंकि उनका जो structure है वो closely packed है and they are hexagonally channels having. So the diameter of these membranes range from 10 to 250 nanometer or maybe greater. These materials is often used as a template for the synthesis of other material. Now these porous aluminum membranes, the materials that made from this porous alumina will act as a template for the synthesis of other nanomaterials. The second example is zeolites. Natural crystalline material with pores having regular arrangements. So zeolites जो हैं they are natural crystalline materials हैं और इनमें pores हैं with regular arrangements. They are also often used in template synthesis of nanomaterial. Zeolites भी as a template act करते हैं for the synthesis of nanomaterial. Selenium can be incorporated into the channels of mordanite, a natural zeolite. Now they have given an example of mordanite, which is a natural zeolite, that selenium can be incorporated into this and then a composite nanomaterial can be formed. The third one is aerogels. Silicon dioxide is the main component of quartz. We know that quartz का जो main component है वो silicon dioxide या silica है. It is chemically robust and finds widespread applications, and silica has widespread applications in multiple disciplines. So aerogels are manufactured with the sol gel technique. We have discussed in previous lectures that to synthesize the nanomaterials, there are different methods like biological, physical, and chemical, in which one of the technique in these methods is sol gel technique. So aerogels जो हैं वो sol gel techniques के जरिए बनाए जाते हैं and can be made of carbon, metal oxide, polymers or silicates, और वो कार्बन, मेटल ऑक्साइड्स, पॉलीमर्स या सिलिकेट्स से बन सकते हैं. Due to high porosity, aerogels have an extremely high surface area and very low thermal conductivity because there are pores in the aerogels. So due to this property, they have high surface area. उनका surface area ज़्यादा है and that's why they have very low thermal conductivity. So if they have low thermal conductivity, they are suitable for thermal insulation. So वो thermal insulation के लिए suitable हैं and as filter materials और filter materials के लिए भी use हो सकते हैं. लो स्पेसिफिक वेट है, मेक them interesting for lightweight construction. So due to low specific weight of aerogels, they are interesting for the lightweight construction applications. So some other properties include the high optical transparencies. Aerogels की जो optical properties हैं वो high हैं. Silica aerogels are made of pores of about 10 nanometer arranged in distances between 10 and 100 nanometer. जो aerogels सिलिका से बनती हैं, सिलिकॉन डाइऑक्साइड से, उनका जो डायामीटर है वो राउंड अबाउट 10 नैनोमीटर है और डिस्टेंसेस बिटवीन दैट इन द एटम्स इज नियरली 10 to 100 nanometer. They are resistant and chemically inert to liquid metals. So they are resistant to liquid metals, heat resistant up to 1200 degree Celsius and non-toxic. So ये जो aerogels हैं non toxic हैं और 1200 degree Celsius तक heat को resist कर सकते हैं. So they have also biomedical applications such as substrates for cell growth and analysis. So they act as a substrate, or uh, the materials produced or made up of these glassy materials act as a substrate for cell growth and their microscopic studies. Thank you.